In this video, we're talking about acid and base properties, generalizations of these acids, and generalizations of these bases. So let's first look at each of the categories. It gives its common name, its chemical formula, how does it taste, litmus paper, and conductivity. Now, conductivity just means does it conduct an electrical charge? Litmus paper is using a neutral piece of paper that indicates whether it's an acid or base by the color that it changes, and its classification is what we're looking at to decide if it is an acid or if it is a base. So let's first look at our acids, the first three. We can notice that we have acetic acid, phosphoric, and hydrochloric acid. Now, yes, they all say acid at the end. That lets us know that they are acids, but they do have in common the IC or the ic after it. And we'll see in a later video that we'll dive deeper into this acid nomenclature. Now, if we look at the chemical formula for our acids here, we're going to see they all have something in common. Yes, they all have an H in front. So when we're talking about Arrhenius acids, to be an acid, it's going to have an H or a hydrogen in front. Now, how many hydrogens depends on the anion or what the formula is on the back end, like the C2H3O2, the PO4, or the Cl. Now, we can notice that all of the acids for this are going to have a sour taste. Acetic acid is found in vinegar, if we're talking about that. If we are talking about lemons and their sour taste, they have citric acid for it. Now, if we're talking about that neutral litmus paper, if we're testing out a substance and it turns red, it is going to have that acidic classification. Now, when we're talking about conductivity, all of these acids, whether they're strong like hydrochloric or weak like acetic or phosphoric, they all do conduct electricity, meaning that they have an electrical charge, or when we saw the demo earlier in the year, that they would have the light bulb shining nice and bright for it. So those are just some properties of our acid properties. Now, if we're talking about our bases, we're going to see that they're the next three going on our chart. Now, their properties can be similar and different to our acid-base properties. Now, if we look at the common names for each of these, we have magnesium hydroxide, aluminum hydroxide, and sodium hydroxide. When we're talking about our base properties, such as our Arrhenius bases, we're going to see that our bases are going to have a hydroxide group or an OH on the back end. So that's why we see that our Mg, Al, and Na all change, but on the back end we have our OH. Now, the same way that we looked at acids, it depends on the charge of our cation to let us know how many OH groups we need to neutralize or set even for our cation in the front and our anion on the back. Now, you'll notice that each of these have a bitter taste. So we like to say that bases are bitter in taste if they're not poisonous for what we're looking for. They also turn our neutral litmus paper blue, whereas acids turned it red. So notice that I changed colors and that we're going to be using reds primarily for our acids and blues for our bases. Now, a property that won't tell you the difference between an acid and base is conductivity, because we'll see that all three of these bases also do conduct, meaning that the light bulb would turn on because there are free ions within the solution. And the classification for all three of these are bases. If we look back, bases are going to have the OH ion in the back, whereas acids are going to have the H ions in front.